Hey guys, this is Professor Janacek, and I want to tell you about line integrals of scalar valued functions. We'll start with f being a scalar valued function on a smooth curve, which we'll call C. F is defined by the vector r of s as x of t, y of t. Notice r works on the arc length s, but it is defined by the parameter t. So the line integral of f along C is, the integral over C of f of x, y, xt, yt ds. Now, computationally, the way we'll actually work these out, of course there's the line integral, but we'll write it as a regular integral over the interval from a to b of f of xy, and remember ds is the same as the square root of x prime squared plus y prime squared dt. But of course, that little bit here in the back is really the magnitude of r prime. So I can compute a line integral over a scalar valued function as the integral from a to b of f of xy times the magnitude of r prime. Let's try an example. Let's compute this line integral of x squared plus y squared ds for C being the line segment from 0 to 5. All right, so we'll have to begin with r naught is going to be the vector that goes to that first point from the origin to the point 0, 0, so it's the vector 0, 0. If you recall, v is the vector from the first point to the second point, so that's 5 minus 0, 5 minus 0, they happen to be the same, so v is the vector 5, 5, which happens to be the vector from the origin to the second point. And then the r that we're going to be using, the form for that is r naught plus vt. Put that together, and that gives us 5t and 5t for our vector. Also notice that in this case, t does go from 0 to 1. All right, now what about r prime? Well, r prime is, r prime is simply the derivative of each of those components, so it's simply 5, 5. And the magnitude of r prime, well, that is 5 squared plus 5 squared. Take the square root of that, and it looks like we get, 5 square root of 2. So now to compute our line integral, we're simply going to take the integral. Notice our t values go from 0 to 1. I am following this right here. And we want f evaluated at x, y. So notice this is x and this is y. And in this situation, feel free to make note that f of xy is x squared plus y squared. So that gives us I made a mistake. That's not xy. Oops. This is xy. It's on r, not r prime. Okay, so x squared would be 5t squared plus y squared, that's also 5t squared. And then we're going to multiply, remember we have to multiply by r, the magnitude of r prime. That's what we determined here. So that's 5 square root of 2 dt. Let's see, if we simplify all this, that's a 5t squared plus 5t squared. And then times another 5 and a square root of 2. Looks like that's going to be 250 square root of 2 t squared dt, which is 250 square root of 2 over 3 t cubed, evaluated from 0 to 1, which is just 250 square root of 2 over 3. And there we go. Not so bad. All right, let's take a look at the second example. Let's take a look at the line integral over c of x minus y plus 2z ds for c, our path being the circle, r of t is equal to 1 plus 3 cosine t, 1 for the first component, 3 cosine t for the second, and 3 sine t for the third. And in this case, t will go from 0 to 2 pi. All right, in this case, we're given r. We did not have to determine that on our own, but we do need to figure out what is r prime. Which, let's see, cosine squared plus sine, oh wait a second, I am getting ahead of myself. I just need to find the derivative before I find the magnitude. The derivative here is 0, negative 3 sine t, and positive 3 cosine t. Now let's find the magnitude of that. Okay, let's see, sine squared plus cosine squared, factor out that 9, square root of that, we end up with just a 3, I believe. Okay, well that's not so bad. Now, to determine our line integral, we will start by rewriting it as a regular integral. Our t values go from 0 to 2 pi. Right, we were given that in the original problem. And don't forget, we have an x, a y, and a z this time. Our function remember, is that integrand x minus y plus 2z. So if we evaluate our function, again, that's what we start. We always start by evaluating the function and then multiplying that by the magnitude of r prime. So we end up with the integrand being 1 minus 3 cosine t plus 2 times 3 sine t. And then we multiply by the magnitude of r prime, that's 3, and then we integrate with respect to t. If we simplify all of this, we end up integrating, let's see, 3 minus 9 cosine t plus 18 sine of t dt, which integrates to 3t minus 9 sine t. Be careful, we're integrating, not differentiating this time. Minus 18 cosine t, evaluated from 0 to 2 pi. Let's see if we do that evaluation. We get 6 pi minus 0 minus 18, and then 0 minus 0, oh, plus 18. Oh, those 18s go away, so we just get 6 pi. Well, there you go. Not too bad. Enjoy.